So tell me what you were saying that you sort of had started this journey. I remember meeting you, a few years back. What went wrong in terms of, you said you're just resuming it. When you said you think you embraced too much too quick, I was really interested to know what actually happened.
Yeah, look, I think in a nutshell, the idea was to reduce our, chemical inputs.
Yeah.
But that really relies on us then getting back with more frequent applications or, getting the biology on there. At that point in time, as soon as it rains and the crop gets pretty big and it's wet, you can't get back in there. So
Yeah.
I think the fundamental difference this time is, we've armed ourselves with a drone. That's fairly easy to do.
That's pretty cool. I was impressed with that. And what sort of things did you, just give me an idea, just so I get a feel for it, having looked at your soil tests and things and knowing what we're dealing with. For one thing, I think you should really use another lab. I think that lab's pretty useless. Their guidelines are terrible. I mean, they're such widespread guidelines for precision nutritionists. I've not, seen such sort of silly guidelines, to be honest, but they don't even measure boron. I've never seen a lab in the world that doesn't measure boron. I mean, what on earth are they thinking,
Yeah, and that's something we'd like to address and get on top of as quick as we can. Yeah.
I honestly think that I find that Melic 3 is better than Colwell and the BS, the two ways that they're testing phosphorus. The Melic 3 gives more. Because we do leaf and soil together, as whenever we can, because you basically see what the plant's accessing. It does matter what's in the soil, but because minerals impact each other so strongly, and high levels of one thing impact another. And in this case, in Paul's case, the big issue is you can't really guess what iron might be doing when you've got 300 parts per million, because iron can shut down copper and zinc and manganese and so forth, and phosphorus for that matter. And you don't know whether that's actually happening. You can't guarantee it is, but you can suspect it is. But leaf testing becomes, in those scenarios, leaf testing is actually more important than soil testing. Do you actually do any leaf tests, Paul?
I haven't for a while. I did do it some years ago.
If you're going to get into it and correct things with foliars and things like that, which is a good strategy, but if you're going to do that, leaf testing, that doesn't have to be huge numbers, but leaf testing is really, really important, because it's you'll see when you get the results that they don't even mirror. It's what you're simply asking is, what do you want, plant? Oh, that's what you want. Okay, here it is, and then you give it through the drone.
Yep.
And what you'll see is that it doesn't mirror the soil test. It never does. And when you've got excesses of one thing, that impacts the uptake of another. And you'd be really concerned that one of the things that we look at on leaf tests, and it's been a really successful strategy and people practice it all over the world, but I sort of came from my mate Gary Zimmer, the American consultant, but it was this concept of, on leaf tests, trying to get luxury levels of 4 minerals, and we call that the big 4. And we find that and this is really important for cane, because it just improves both production and sugar levels, but it's all about, because the 4 minerals are all relative to photosynthesis. So that calcium, of course, the big one, but calcium and boron, which is not even measured on the soil test, but it's actually considered to be one of the big 4, because calcium doesn't work without it. So calcium, boron, phosphorus, and magnesium. And it turns out that there's 2 synergists involved, because boron drives calcium and magnesium drives phosphorus. And so what you want is, you get a range on a dry leaf test of, say 3 to 17 for boron. Well, you want 17. That's called a luxury level. You want the top end of the acceptable range for all 4 of those minerals. And if you can achieve that, you just optimize production, profitability, and disease pressure and sugar levels in the cane. So it's a really good thing to work toward, and you'll see that you would suspect immediately, because there's so many calcium deficiencies there, that calcium is going to be low, but it's not always the case, because different soils give up their calcium at different rates, and it also depends on things like the biology. Like fungi are hugely important in the delivery of calcium. They're sort of calcium deliverers is one of their roles. And so what's not measured on the soil test, and which I'd strongly advise that you look at, I'm pouring out stuff at 100 miles an hour here as well, but I'll be recording it, so I can send you the recording.
That'd be great. Okay.
What I strongly advise is that you just invest that $290, and you can buy them through Amazon or us. It's all the same price. For a microbiometer, it's so important. So the 2 things that you're managing, the very simple thing is that the 2 things that you're managing when you grow any crop, including cane and pasture, You're managing gas exchange, so you're managing how freely does the most important single element for growing crops is not N, it's not P, it's not K, it's not calcium, it's oxygen. And how well that soil breathes is the essence of productivity and profitability. And so there's two things that govern that thing called gas exchange, because gas exchange is how freely does oxygen move in from the atmosphere. It's called diffusing, where a gas moves from a high concentration to a low just automatically. But how freely can it do that to feed the organisms who are all oxygen dependent and the roots that use oxygen for everything? So how freely, and then when they've used their oxygen, that same situation applies. How freely does the CO2, which is now abundant because they breathe out CO2, the organisms and the roots breathe out CO2, and now it diffuses up, and the plant leaf's got little mouths called stomates, sucks them up, and that's the basis of photosynthesis, and that's how you grow stuff. So the better you do gas exchange, the better you do. And there's two things that govern gas exchange, and one of them is the cal-mag ratio, because calcium's a great big beach ball of an ion, because all ions vary on their size. So you've got this great big ball with two charges that grabs hold of clay on either side and pushes apart the clay, and that's called flocculation. That's why calcium opens the soil. And then magnesium's like a little golf ball in comparison. If you've got high magnesium, the magnesium can grab the clay, and of course it depends on how much clay you've got in the soil, but it grabs the clay on either side with its two charges and pulls it, tightens up the soil, and then you've got platform shoes in the wet, and you've got a soil they call a Sunday soil. You work it Saturday, you plant it Sunday, Monday it's tightened over. And so you might say, I'll forget the magnesium, I'll just do the liming, I'll just put calcium on, but you can't forget magnesium, because you've got two roles. Your second role, so number one is you're managing gas exchange, how well does oxygen come in and CO2 come out, so how open and friable is that soil. And then your second role you're managing, and especially you can really dumb it down to saying there's two things you do, and the better you do, then the better you do. And so the second thing you're managing is chlorophyll. You're managing the green pigment that houses the little sugar factories called chloroplasts, and you don't want stripes or pale colours or late season lower leaf burnt outer margins, which is potassium deficiency, which I'd suspect in some of these blocks. So that's why you can't forget magnesium. So it's about that ratio, and in many of the blocks you're really calcium deficient, and there's quite high magnesium in some of those blocks. So high magnesium in terms of its antagonisms, well, it can antagonize calcium. It's really antagonistic of potassium, and potassium is just marginal, but you don't know, because sometimes it's, in some soils it will deliver. So that's why a leaf test just shows you, or a nitrogen and a potassium meter in the field. So the potassium meter is real simple. It's really simple to use, because you just take a first fully developed leaf on the cane or the pasture, and then you take a lower leaf. And you need to have exactly the same parts per million, because potassium is the most mobile mineral, and the moment you're deficient, it just races from the lower leaves to the top end of the plant where it's needed for growing tips and so forth. So you just want to maintain, you never want, as soon as there's 10% less in the bottom leaf, then you need to foliar spray some potassium. And the best choice, I'm maybe not here, but the best choice by far is potassium sulphate, because your soils are one of the biggest major mineral deficiencies is sulphur. It's really, really low when you only got 5 and 6 parts per million, and you need 40 or 50 parts per million. So it's really important to understand how important that mineral is. I mean, the whole productivity and protective nature of the plant's driven by protein, and protein's made from sulfur. I mean, protein, the two amino acids, most important amino acids that make up, there's 19 of them, but the two most important are called cysteine and methionine, and they're made from sulfur, and you've got bugger all sulfur there. So, when you're talking about even trying these micronized limes, I would be doing micronized lime and micronized gypsum together if you're going to do that, because you just need sulfur. I'd even trial a few rows of elemental sulfur, but the problem is that the calcium deficiency in most blocks is, so you don't want to put sulfur on if you only got a pH of 5.5. You can get away with it when you get to 6, because it's acidifying, and you don't need any more acidification there. Yeah, so that's my opening rave. It's just whatever comes to my head, which is the way I do things.
So you're confident in the microbiometer, Graeme? I've got one, and I've played with it.
It's just a rough guideline. You've got to take it. There's a few little criteria. You've got to take it from right beside the plant roots.
Okay.
So there's no point just taking an empty paddock. It's all about all the guidelines and everything are based on the highest possible reading, which is where the plant's feeding the organisms via its roots. So you scrape the soil off the roots.
Righto, yep.
That's number one. Number two, it used to be 20 minutes. It's now half an hour that you wait for the test.
Okay.
For it to be cured after you've done you know how it works and so forth. Then it used to be the guidelines of 20, and now they've shown that half an hour is more reliable. Okay. But what I find with it is that it can be the biggest paradigm shifter. Like I've just come back from Europe, and you can walk fields, all over the world where you can go on a farm where no one's ever thought about any of these ideas in their life. They just thought the soil was something you stood the plant up and chucked some chemical fert and some chemicals to solve the problems that came from the chemical fert. And they just thought that's how it worked. And some of them got degrees in agronomy and they were taught that's how it worked. And so you just go onto their paddock and you say, okay, show me your best block, show me your worst block, because everyone's got one. You've got a paddock that always does good. You don't necessarily know why. It's just the paddock that performs. And then you've got the paddock that costs you money every year. So we test those and they're looking over your shoulder and the results come up, and it's never an exception. It's always, that's what gives me a little bit of confidence in the validity of that device, because there's never, the good block measures 700 and the bad block measures 120 or something, measures 120. And so immediately you see this, oh my God, the microbes are making me the money. It's just like this penny dropping experience for the growers involved. And it's the biggest paradigm shifter. You've got your set of beliefs and how things work, the biggest sort of change in a short time of anything I've ever seen in the field, because it's not sometimes, it's always the best block. I mean, you can do it on your farm, and for your own confidence, do the best block, do the worst block, and you'll see the difference.
Yep.
And that's in a traditional synthetic system, Graeme, that you're measuring that biology difference.
That's right. Yeah, that's in the system. So for a variety of reasons that they don't necessarily understand, and it'll be all sorts of things like percentages of organic matter and a whole range of other things, including the Cal-Mag ratio, that soil's is breathing best, and the soil and the organisms are thriving best, and they're performing and delivering best. And then you know that, you understand, I mean, oh my God, if I look after them, they look after me. And that's sort of the paradigm shift, to realize that you're dealing with a living system that impacts every aspect of what you're doing, including your profitability and productivity. And you just make a simple decision then, well, I'll try and do all I can to minimize the impact on these guys that are delivering everything. I'll look after them and they look after me. It's this kind of change in mindset, because you suddenly realize their importance. But that machine has been so valuable for that purpose. Yeah. So tell me about your experiences with it, Paul.
Oh, I just got really, really low levels, and maybe it is a good indicator.
What kind of levels are they?
I can't even recall, to be honest, but they were, they'd say do it again, put more drops on it, like it'd be really low,
So you're stirring it up for the 30 seconds.
Yeah, following the recipe, and I just.
There's one thing. Have you got the one with the little magnet in it?
A little magnet.
Yeah, all the kits now come with a little magnet in them, and they're really unreliable on high iron soils, because iron impacts the readings. And so you have a little magnet, and you touch this little square magnet that comes in the kit. It might be in there, you might not have ever seen it in the bottom.
Yeah.
Tap the test tube after you've set it all up with the test tube, and you're waiting for your half an hour. Twice during that half hour for 30 seconds, you just tap that on the bottom, and it pulls the iron into the sludge on the bottom. And then the iron doesn't affect the biology.
Righto. Yeah. I'll get onto that.
Yeah, so you might see some difference in results then.
Okay, that'll be good.
So you're looking at total microbial biomass, and so when we're talking about that gas exchange concept, we're talking about equal importance. The calcium to magnesium ratio is the physical structure change with the chemistry, the soil chemistry with the calcium magnesium balance, and the second thing is the biological one, and that's the importance of this fungi to bacteria ratio. And what you're chasing ideally is a 1-to-1 ratio for cane, actually for everything they're now finding is on that meter is a 1-to-1, and what you see most times is 95. And one of the things that can make a difference, and that's why I'll ask this question. I mean, have you used Sugarcane for pineapple disease in the past or not?
Not for a long time.
Oh, it should be fine by now. Yeah. It's just that mercury is, I mean, that's why they used it, but there's actually nothing more toxic. It's the most toxic known substance on the planet. And there's no safe dose, even parts per million. And that's why it was a silly idea to put mercury in our mouths. And our eating of tuna, well, we don't even have heavy industry that can give tuna mercury, but we do have the cane industry using sugarcane back in the day, and that's the problem with leeches. And the top-end fish pick it up and become toxic sort of thing. But it's really toxic for soil life. That's the problem.
Your microbiometer, Paul and Graeme, is that giving you your fungi to bacteria ratio?
Yeah, it gives you both. It gives you total microbial biomass, and there's lots of studies showing that that's a guideline to productivity. So it's just how big is your workforce. So that's called microbial biomass. Doesn't say what organisms, it just tells you what you got. But the higher it is, the better it is. And then it gives you the fungi to bacteria ratio, which needs to be 1-to-1, and which in many soils is. I mean, the visible thing for you on the farms is how fast does the trash break down, because it's only fungi that can do that job. So does the trash break down very well or not?
Pretty much gone within 12 months.
Yeah, but it should be really 2 months that it's broken.
Yeah, it's certainly still there.
Yeah. So that's an important. So then you sort of change your focus of it. So, okay, how can I get fungi out there, and how can I stimulate them up and all that sort of thing?
Yeah, yep.
So it's a really worthwhile little part of your testing equation. So the testing equation, in my opinion, you probably should try using EAL, or I could probably organise via my account with the US lab because it's quite cheap. But we need, if you're going to do a few tests between you, we could probably send it to the US Brookside, which is the lab that Albrecht set up originally. And they measure cobalt and selenium and silica and molybdenum and all those kind of things. And it's quite a lot cheaper than ordinary tests, but you need a few to justify putting them in a bag and shipping them off with DHL, because if you only got one or two, it's bloody expensive to ship. But that's someone, or EAL, who kind of copied part of that Brookside model. But just to get because I mean, what's the reason that they wouldn't measure boron? I mean, what lab doesn't measure boron? I've never seen that before.
The sugar industry.
Yeah,
I think I found a note the other day where they, in one of their nutrition manuals, it really states in there that they reckon they've never seen a deficiency in boron in sugarcane in Australia.
Oh, nonsense.
But it's crazy.
I mean the thing from your pasture perspective is, because it's easier to look at. But I mean, have you got legumes in the pasture? Operate legumes in the pasture at the moment or not?
We're going pretty hard at trying to get legumes into it, but I sort of suspect that we've got some issues there because they just don't persist that long.
Yeah, that's what I suspect. Well, so the chief suspects are 3 minerals, and we already know one of them's super deficient. That's sulphur, because you can't nodulate without sulphur.
Yeah.
So sulphur's there, boron's there. Boron's hugely important in the whole nitrogen fixation process. So boron, sulphur, and the little also wasn't tested. The little trace mineral molybdenum. You can't, So when you've got legumes, basically you check to see if they've got nodules. And if they haven't, that's sulphur and boron, or either or, but usually sulphur's the biggest player. And then the nodules have to have a red color. It's called leg hemoglobin inside them. If they're small little nodules in clover, you can just squash them on a sheet of white paper, or you can cut them with a pocket knife and have a look at the larger nodules. But they've got to have the red color inside, which is called leg hemoglobin. And if they don't have, and 50% of them that you look at don't have, then they're not fixing nitrogen. They're not giving any of the what are called eco-service functions that legumes are supposed to bring to the party. And those functions are fixing nitrogen, obviously, releasing an acid that legumes do uniquely that breaks the bond between locked up phosphate and calcium and delivers those 2 minerals to the cane crop if you've got the legume underplanted, for example, or to the ryegrass or whatever grass species you've got. But the fourth role is really important, because the fourth role is that acid exudate that legumes produce. That's what fungi love, and fungi proliferate. If you measure the legume, the soil off the legume versus the soil off the grass, you'll find it's got sometimes double the amount of fungi on it, because that's where they hang out. But they only hang out if it's a functioning legume. So a functioning legume means it's got nodules and it's got red inside. Because if it doesn't have red inside, none of those things are happening, basically. There's no nitrogen fixation, there's no acid exudate that feeds fungi and breaks the bond between calcium and phosphate. So you're not getting free nitrogen, free calcium, free phosphate, and free fungal stimulation. You're getting nothing. You've got a parasite sitting in the paddock if you don't have nodules and they don't have red inside them. That's called a functioning legume. and about 60% of the paddocks you walk don't have functioning legumes. So it's not hard to fix, but you need to be aware of it.
Yep. Okay. Good one.
You're talking about some minerals for that legume to work. When we plant legumes, we plant with an inoculant. Is that pretty important, or is that a requirement?
So it's like a safety valve. You can, often soils have those rhizobium in them, but you just to be sure, because they won't go very far, very fast if they've been killed off or they're not present in the soil. Once you've done it once, you don't really need to do it again in that block, because the rhizobium will persist. But it's just a safety valve thing. To make sure that you've got them, because otherwise you can't do anything without them. You can make nodules, and then there's no rhizobium to go into the nodules, so because they're the organisms that live in there and fix the nitrogen. So it's just a safety thing.
Yeah, no negative effects by using those inoculant products.
No, nothing at all. They're just biology. It's just rhizobium organisms on the seed.
Yeah.
So you growing? So have either of you ever done any sort of interplanting or doing anything else with the cane?
Only fallow crops, just green manure cover crops historically.
Under it or beforehand?
During the fallow period when there's no cane.
Okay, but you don't actually do any underplanting of the cane?
No.
It'd be interesting.
I had a little play a few years ago with some radishes, and that was...
Yeah, I mean, there's really good research out of Brazil and some of the bigger cane producers, even Thailand, where they're actually growing. I just can't figure it because I've not seen it, but they're growing things like fava beans, which is broad beans basically. You can grow the livestock version of it, or you could, I'm thinking, why wouldn't you grow the human version? But there's good money in broad beans. But I'm just wondering how the hell you harvest them. They're just a 100-day crop that you do when you first plant the cane, and it kicks off the cane because as long as that legume's functioning, it's delivering some nice nitrogen and other benefits to the cane, the calcium and phosphate that it breaks apart and so forth. And they seem to have some really good productivity increases and things with it, but it doesn't seem like anyone does that here. And so do you know of anyone who's used a legume like that under the plant?
No, not any scale, no.
Yeah, how do you harvest? I mean, it's only 120 days. How would you get in and harvest it without hurting the cane at that point? I just can't quite picture it.
I can't either. I think it's by hand.
Yeah, maybe it is. So we'll go through some of your questions and some of your stories. So just out of interest, with the sulphur, have you ever put sulphur in or tried using sulphur anywhere along the way?
Oh, look, every crop gets 10 or 15 kilos of sulphur annually. Never seems to raise the level in a soil sample.
Okay. No, because that's about what will be used.
Yeah, exactly.
A lot of sulphur used. So at least you're putting it in there. So when you mentioned in one of the statements using a more user-friendly form of potassium, or not user-friendly, but a softer form of potassium, what potassium have you been using today?
But traditionally, industry uses, potassium chloride because it's the cheapest.
I see, yeah.
In the last couple of years, we've gone over to the Dunder product out of the Serena distillery. Yeah.
And have you measured that with your microbiometer to see that it's...
No, I haven't at all.
It's really interesting to know if there's anything toxic in it. That's all. If you've got those low readings, that's one of the things to be careful of. Like I've just had these, see, that's what those meters can be really valuable. Like I just had this 2 growers in 1 week from South Australia who've been fertigating with large amounts of liquid fish, and they're buying this tuna-based product. It's like only $1.50 a litre or something. And the microbiome and readings have halved in the time they were doing this. And what the hell? We're going down. We were 400, now we're 170. What's happening? And I said, well, basically all mercury's got that, all tuna's got that contamination. It's the top level of fish that sucks up mercury, and mercury is just super toxic to soil life. And that turned out to be what it was. So, so you just got to be careful with these things, because I don't know what's in the Dunder. I've never checked. I know it seems like it's a reasonable deal. But the other thing
it's only really molasses going in, and they just distill off the alcohol off it. So
there's no chemicals that could be that are used in that.
Well, they actually do register as organic.
Oh, well, that's okay. Well, that'd be fine. Yeah, good. That's good.
It's just a straight dunder, yeah. Otherwise,
the other thing, depending on what's available to you, is that, you know, from a phosphate point of view, some of the blocks have actually got good levels of phosphate, so you don't, for some reason, the grazing property, some of them are quite good levels, but there's a couple that are more marginal. But the best source of basically phosphate, obviously, but also NPK and trace minerals in terms of cost is just chicken manure. If you can get a good chicken manure, if you can get your hands on one that doesn't have too much sawdust. Sometimes they do it, they run it through twice or something in the chicken houses, but we can buy it here delivered on farm for $30 a cubic meter. And if you just do the sums of what you're getting for that, well, you just think about it, you know, say it was, well, the one we got most recently was 322. So 3% N is 30 kilos of N per tonne, which is 63 kilos of urea, which is $40 and you paid 30 for it. And then your 2% P is 20 kilos of P, which is the same as actually 100 kilos of DAP. So you got over $100 worth. And actually, when you add it all up, it comes just under $300 that you bought for $30. And it's like the bargain of all bargains if it's close to hand and you haven't got a high freight component. It's got all the trace minerals and quite good levels. And people say, oh, yeah, but I don't want to put raw manure in. But you can use these lactobacillus things that you're using. You can use BAM or EM or even the do-it-yourself ones, then just spray, put it out and spray it. You can do it. Some people do it at the same time, and it'll just compost in situ really quickly. BAM has got organisms that are facultative anaerobes that operate with or without oxygen, but when in oxygen scenarios, they become almost hyperactive. There's an organism called Lactobacillus plantarum, which is the most voracious known cellulose digester, so it gets ripping into that chicken manure. And so you made the equivalent of a $500 or $700 a tonne composted pelleted fertilizer that you just made in the paddock for $30 sort of thing, plus the cost of a bit of inoculum.
Yep.
Yeah, but that's a really good delivery of the whole spectrum for a low cost. That's all. If you can, do you have chicken houses up there or anything?
No, there's not a lot here.
Okay.
What about, are you happy with like mill mud, the filter press from the mill? You know, that's the most available source of phosphorus for us. Is that?
What have you been? I mean, that's
that's how we got higher phosphorus levels in a lot of those paddocks.
Phosphorus levels aren't. I mean, it's very easy when you've got those high phosphorus levels to. I mean, I can see you're doing the good thing with just 20 kilos of DAP just to make sure you've got a little bit of soluble starter. But using biology then to release that is a really good thing. One of the new things I think you really could look at brewing wise, if you've got brewing facilities, is this organism Pseudomonas fluorescens. So there's this whole new understanding that the silica, particularly for cane, I mean, it's one of the biggest silica users, but you need to have silica in what's called the monosilicic acid form. And when you do this soil test, you need 100 parts per million, and you've got sort of 30 and 40 and things, and that's really common. And the most common reason for that is knocking out the silica solubilizing organisms. Now they discovered that Pseudomonas fluorescens is the most powerful, but it's the first thing that goes with glyphosate. Glyphosate just kills it on the spot. So do you use glyphosate in the program at all or not?
Yeah, I still have been. I think he's knocked his off.
No, I haven't used glyphosate for a number of years.
Yeah, so glyphosate's just, I mean, it's not denied or anything. Monsanto tried to launch a bug, a Pseudomonas fluorescens inoculum that didn't die from, it was a GM organism that wouldn't die from glyphosate because they acknowledged it was a problem. Because take all, for example, in Europe's gone ballistic because the only thing that controls it is Pseudomonas fluorescens, and they're all using no-till with glyphosate. So that's the reason it's sort of run rampant. But they weren't allowed to put out that GM version because we haven't yet put out a GM bug, and you can't call it back if something goes wrong. If it messes up the whole ecosystem or something, we don't really know because there's so much interplay between everything. It's really sort of gambling when you do that. So they didn't do that, but that was acknowledging that's the reason when we look at sort of less chemical blocks, the more regenerative blocks where they haven't been using glyphosate, you'll see higher levels of plant available silica, and that's the reason. But you can brew up this organism, and it doesn't just solubilize silica. It controls a whole suite of diseases, and it's a really good phosphate solubilizer. So it becomes something you can brew up and really sort of help release that phosphate, and it protects from a whole suite of disease. It boosts plant immunity, produces 3 or 4 biochemicals that stimulate immunity to give you fungal protection and so forth. So that would be a good sort of, if you've got brewing facilities, it can be really inexpensive to brew your own. I teach how to do it on one of the videos.
Yep.
Yeah.
Seen that? Yep.
Yeah, and it can be really, really good.
Okay. Excellent.
So running back through, let's just go back through your original email. Let's just talk about nitrogen, because I see you didn't have any in your starter blend. Where's the nitrogen coming from? I mean, it's the most abundant mineral. You've got to get it coming in from somewhere. So tell me about your nitrogen program.
Yeah, just going down a bit of a track of trying to match nitrogen demand from the crop to our applications. So just trying to push it out further now that we can put it on later.
But how are you doing that? If you haven't been doing leaf tests?
Yeah, good question. No, we we haven't started really this bloody small applications often with the drone yet. We've only just purchased that. Got license.
So I think it'll be a good investment. I work with large grower groups, doing these consults all over the world, and probably 1 in 5 of them are now buying these 50-litre drones. And I just think that they've got, and we've demonstrated them. So had one of the drone guys come out to our last 2 field days and demonstrate them, and they do. I mean, they were just demonstrating foliar spray in a cover crop, multi-species cover crop, but they're pushing it down in there, and it's less water rate than what you'd normally use, but it gives good coverage, and I think it's going to be the next step sort of thing, particularly for cane, because you can't get on the paddock once it's out of hand. So
that's right.
gives you that control. I think it'll be a really good investment.
Yeah. Yep.
I just don't know how you can get by. I haven't done enough myself with it to know, and that my agronomy team hasn't to know when you're talking about. So let's just explain the urea concept as a foliar. So there are 3 types of nitrogen. There's the ammonium form, the nitrate form, and the amine form. Yep. But basically, urea is uniquely the amine form, and it's a natural thing in essence, because it's what's in urea. It's what's in urine. That's where the word urine comes from, because the nitrogen in there is that amine form called urea. But what we've done is use this Haber-Bosch technique, powered by a lot of energy with gas and so forth, to drive it to harvest it from the atmosphere and make our own version of that natural thing. But it's essentially a natural compound, like in Cuba, where they out yield us in sugarcane. They foliar spray urea, because they can't get bugger all of it, and they can't put it on the ground because they've had all those oil embargoes. So they get a little bit from Venezuela, and what they get, they foliar spray. But they actually allow it. They're 42% certified organic, and they allow foliar spray only urea, 10 kilos a week and no more, in vegetable crops and things like that as part of organics. So let's just point out why it's so much more sustainable. The first thing to recognise is that from the point of view of greenhouse gases, it's underplayed horribly, because when we look at agriculture's contribution to that blanket of greenhouse gases, 25% of the CO2 comes from agriculture, and mostly that's to do with nitrogen mismanagement, because every kilogram of nitrogen you put in over and above what the plant needs. That's why it's great that you're doing this plant requirement based on plant requirements. But every kilogram you put on over and above, like putting a whole bunch under a plant at the start of the season, is like a leaching soil, is really silly. But basically, every kilogram over and above what that young plant needs, you burn 100 kilograms of carbon that becomes nitrous. 100 kilograms of carbon that becomes CO2 in the atmosphere. There's a whole process. I won't go into it how that works, but it's quite well researched. They've radioactively tagged to say what it does. So mismanagement of nitrogen is a huge player, but it's also agriculture's 60% of the methane and 80% of the nitrous oxide. And you might say, well, that's no big deal. It's only 5.5% of the pie, but it's 310 times more thickening of that blanket than what CO2 is. So it's actually a huge story that we're mismanaging nitrogen. And that's where the foliar spray and urea can be such a good tool. So basically, when you put urea, say you've planted with a bit of urea, that amine form, almost instantly, the urease enzyme converts it into the ammonium form, and then it sits on the clay colloid, because ammonium's a cation that sticks on clay. And then if there's warmth and moisture, nitrifying bacteria come woofing in, and they convert it. Most of that, the vast majority of it's converted to nitrates. And then the nitrate form goes into the plant. And then there's this big suck of energy. It actually involves the trace mineral called molybdenum. It's and the enzyme that's molybdenum dependent. It's called the nitrate reductase enzyme. And that sucks 17% of all your photosynthetic energy, which is sugar in your cane, just to convert it to the first stage of protein. And the first stage of protein is called an amine. And then you think, wait a minute, what would happen if I bypassed all of that and the off-gassing and the leaching, part of which happens all the way through that process because nitrate's so volatile. If I bypassed all that 12 times more efficiently, which is what foliar spraying is, foliar spray the amine straight on the leaf, it goes click amino acid, click protein with no energy suck, no loss of bank account for you, really. It's just the most efficient. You always put humic acid with it because that creates a urea humate that can't off-gas and can't volatilize, can't leach. And then not that much is going to leach because most of it's going onto the plant anyway. And that's really the most efficient way you'll ever put nitrogen on. And it really is the kind of solution.